Linear search is a simple search algorithm. It checks each element in the list one by one until the target value is found or the list ends. Here's how it works. Start from the first element. Compare each element with the target value. If it matches, return the index. If it doesn't, move to the next element. Repeat the process until the target is found or the end of the list is reached. The time complexity of linear search is O(n), meaning it takes linear time to search through the list. The space complexity is O(1), since it only requires a constant amount of extra memory. Linear search is best used for small or unsorted lists. It's quick to implement and doesn't require sorting of the dataset. Let's implement linear search in Python. Here's a simple code example. Def linear_search, arranged by target. For index, value in enumerate, arranged by if value equals target. Return -1 not found. In this code, the function loops through the list, checking if the current value matches the target. If the value is found, it returns the index. If not, it returns -1 to indicate the target wasn't found in the list. Let's test this with an example. Numbers equals 5, 3, 8, 4, 2. Target equals 4. Result equals linear_search, numbers, target. Print, ftarget found at index, result. When the code is run, it will output, target found at index 3 inches since 4 is at index 3 in the list. The pros of linear search are that it's easy to implement and works on unsorted data. However, its cons include being inefficient for large datasets, as more efficient algorithms like binary search work faster with sorted data. In conclusion, linear search is a simple algorithm that's perfect for small, unsorted datasets, but for larger data, more efficient algorithms may be needed.